Hi, I'm Andrew Stevenson, and this is my clustering assignment. So first thing I did was went on the site and grabbed a data set called this a seeds data set, which contains different attributes of three types of wheat seeds. So once I loaded that into R, I noticed that the data columns were just generic V1, V2, etc. So I changed the names of the columns just to make it a little easier to understand which attribute is which. Um, Checked if the data had any missing data, and it didn't. Um, then after looking at the data, I realized that the seed column just had values that were from 1 to 3, so just 1, 2, and 3 to represent the different seed types. And I wanted to change that to make it a little bit easier to identify which is which. So I looked through all the data and changed. 1 was the Kama seed, and 2 the Rosa, and 3 the Canadian. So I changed that inside the data, and then just double check to make sure that that change was made, using both the unique and looking at the first set of values. So to start clustering, I created a new data set I called my data 2 right here, and started with the k-means clustering method. So in my assignment, I actually used 3 different methods. So the first one I did was the k-means, and after running that clustering method, looking for 3 clusters, hopefully trying to identify 3 clusters of seeds, I checked that against the original data. It looked like the first cluster was for the Rosa seed, 2 for Kama, and 3 for Canadian, with a few outliers or points that didn't get inside the cluster correctly. So then I plotted that. Pretty simple, the 3 different clusters and which data points are inside of each. And then I used the cluster library and the clustplot function to actually draw a plot that circles each of the clusters and colors them differently. So that's there. The second method I used for clustering was the PAM method, which stands for partitioning around metoids. So I ran that and again compared it to the original data, and it had the first cluster being Kama, the second Canadian, and 3 Rosa, with again some outliers, but clustering pretty well in general. I went on to plot that, just same as the other plot I used for k-means. You can see those 3 different clusters where all those data points are located, and then again the fancier plot, the cluster plot that circles the clusters. And then the last method I used was the Ward hierarchical clustering method, which requires a distance matrix as an input versus just the straight data. So the first thing I had to do was create this distance matrix right here, and set the method to Euclidean through the data. And then I clustered using this hclust function with the method being Ward D. And then I cut, this method actually just clusters hierarchically a bunch of different clusters. So I cut it to actually 3 right here so that I could just see the 3, hopefully representing the 3 different seeds. And then I applied that. And as you can see, here's my clusters 1, 2, and 3 with my data. And it seems to cluster pretty well here with this grouping, this grouping, and this grouping, with these outliers here and also over here. And then the last thing I did was I wanted to plot a dendrogram of the cluster, so like a hierarchy graph basically. And so I used the plot function for the cluster, and this other thing to add, just rectangulars dot hclust, which actually puts borders around whatever number of clusters you want to put borders around. So I did set it to 3, again being representative of those 3 seed types, and with a red border. And so scroll down, and here's that plot with the 3 different clusters within the dendrogram. You can't tell directly from here which seed is which, but you could probably figure that out by like the number of seeds. I think like the Canadian might be this one because it had more data points than the others. So that's it. Thank you.